Welcome back to CSConnect series. This video will be dedicated to arithmetic operations. The usual addition, multiplication and subtraction, but not with the usual decimal number, but with any base number. So whenever you do decimal number addition or decimal number subtraction, you make sure you use the digits only from 0 to 9. What happens if you are restricting the base and asking you to do the same arithmetic operation? So we are in digital electronics content, and under number systems, we are into arithmetic operations here. Say for example, if I give a number in octal or if I give a number in binary, you can convert them to decimal and then do addition or subtraction or multiplication and then find the binary equivalent again and give the answer. But in this video, you will not convert this to decimal but work it out completely using a particular base system. Now we'll get on to the video. Arithmetic operations in base are, it means you are not going to convert it to any form but do the addition or do the subtraction in the same base. We are going to concentrate on addition, multiplication and subtraction. How are we going to do these process? They have the same rules as for decimal numbers. But make sure we are going to use only R allowable digits. It means when I use base 2, I have to use only zeros and ones. When I use base 3, I have to use only 0, 1, 2. When I use base 8, it should be from 0 to 7. I should not use 8 or I should not go below 0. So now let's get on to addition. We are going to learn addition using binary. So I have kept the numbers of 0, 1, 2, 3. The representations are here. Now we will go for addition. For addition, we will take two numbers. The first number will be called as augend and the second number will be called as addend. I cannot say I am using the first number, I am using the second number. Every number has a name. How will I perform addition here? 1 plus 1. What is 1 plus 1? 2. What is 2 in binary? 1, 0. Actually, when I write 1 plus 1, I should write it as 2. But this is decimal format. I can calculate it as 2, but I cannot represent here it as 2. So 1, 0. When I have a number like 1, 3 or 1, 4, we usually write the units position in the answer. The tens position we will be using it as carry. Instead of 2, I am placing 0 here and 1 will be kept in the carry. So this 1, 0 is 0 is in sum and 1 is in carry. 1 plus 0 is 1. Then 1 plus 1 is again 2. So again I have 1, 0 representation. So 0 here and 1 here. Now let me add this. 1 plus 1 is equal to 2. 2 plus 1 is equal to 3. What is 3? 1 and 1. You can either go with 1 plus 1 plus 1 is equal to 3 or 1 plus 1 is actually 2 which is 1 0 and 1 0 plus 1 will give 1 1 which is equal to 3 again. Altogether I want something in binary. You can interpret it either this way or this way, it depends on your mind. 3 is represented as 1 1. So 1 will be present here and 1 will be present here. Again 1 plus 1 will give you 1 0. So 0 is here and 1 is here. Then 1 plus 0 is 1 and again I have a 0. So this is going to be 1 again. So 1 plus 2 zeros will give you 1. And what is 1 plus 1 here again? It is 1 0. Since there are no more numbers, I am just writing the answer like this. This is how we have to add. What is the answer here? It is 1 0 1 0 1 0 0. This is the value of the sum. Now we will move on to multiplication. So the first number we are going to take is the multiplicand and the number that we are going to multiply with it is multiplier. How will we do this multiplication? Basically, we will be taking the complete multiplicand and we will be using only one digit of the multiplier. So similarly we will be doing 1 0 1 1. The complete multiplicand is taken into the first digit of the multiplier. This is equal to, what is 1 into 1? 1. There is no change in the process of addition or multiplication. You are going to do it in the same way. The representation is alone going to change. Now the second digit. What is 1 into 1 again? It is 1. What is 0 into 1? It is 0. What is 1 into 1? It is 1. Actually, we will get the same number, there is no doubt. But the thing is, we are doing it digit by digit. Now, 1011 is represented. The next digit. 1011 into 0. Anything into 0 will give you 0 for sure. So, we will represent 0 here. What about the third one? It is again 1. You will end up with the same digit 1011 and we will represent it here. This is how we will be representing in decimal part. 1 step ahead and 2 step ahead, the same thing we are using. We have to find the product by adding all these 3. Now we will go for addition. 1 and we can just take this as 0. So 1 will be here. Then 1 plus 0 will give you 1. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1, 0. We are getting into this part. So 0 is placed here and 1 carry is placed here. Now 1 plus 0 will give you 1 and this one has no numbers in the top, so 1 is placed as it is. So the answer will be 110111. So this is the product. So all these steps are similar to decimal number system. The only thing is you make sure you don't use any number other than 0 and 1 to represent. The next operation is subtraction. The first number is called the minuend and the second number is called the subtrahend. So what is the difference? 1 minus 1 is 0. What is 0 minus 1? How should I proceed with it? When we have a number like 1, 2, 3 and 0, 9, 1. 3 minus 1 we have 2. We will borrow something from the previous number. We will make this as 0 and we will make this as 12. Now we will do the same thing here. In order to subtract 1, we need a number higher than 1. So what is the number higher than 1? It is 2. So what is the representation of 2? It is 1, 0. So we are borrowing 2 here. Instead of 2, I have to use 1, 0. So remember, 0 is less than 1. So I need to subtract from a higher number. So I am going to subtract it like 2 minus 1. What is 2? It is 1, 0 in binary. So this is the format I am going to bring it. When I actually borrow something, the previous digit should be reduced. So I am reducing this to 0. When I borrow this number, I reduce this number. Since I am taking 2 from this, I am reducing it to 0. Bluntly, if you see, it is 10 minus 1. But in binary, it is 2 minus 1. So 1, 0 is 2 and 1 is 1. What is 2 minus 1? It is 1. So I can place 1 here. These 2 digits are done. Now move to the third digit. Now you have 0 minus 1. What should you do? You should again take a borrow and make this as 1, 0. So what is 1, 0 minus 1? It is 1 again. Now 0 minus 0 is 0. Then 0 minus 0 is 0. 1 minus 1 is also 0. The difference will be, you can either write it like this or you can leave out the zeros preceding the 1. You can also mention this way. This subtraction is a complicated process compared to addition and multiplication. What kind of complication it's adding? It borrows 1, 0, that is 2 to minuend digit. So which digit is here? Minuend. So it is borrowing 2 and replaces the previous 1 by 0. Whatever I did here, that is what is explained in words. So you can ask me, borrowing is a simple thing, replacing 1 by 0 is a simple thing, everything is simple in paper and pencil. When it comes to digital, you have to make computers work according to it. So as for now, we will just wind up with these operations. Arithmetic operations, practice problems. Now we have worked with binary. The practice problems will have another base. Add the numbers in the given base without converting to decimal. It means you are going to add it in base 6 only. Let's take the first 6 digits. 0, 1, 2, 3, 4, 5 are there. So what will happen to 6, 7, 8, 9? So you have to repeat this 0, 1. So 0, 1, 2, 3. I am just repeating. And then now you have to place 1, 1, 1, 1. This is how you will be forming as we did for 10, 11, 12, 13, 14, 15. In decimal, the similar process we are using. So this is 1 into 6 power 1, which is equal to 6. Then we have 6 plus 1 into 6 power 0, which is equal to 7. Then 6 plus 2, which is equal to 8. Then 6 plus 3, which is equal to 9. As for now, I think these 4 digits are enough. Now let's get into the problem. Let's take the augment 135.4. Now you check whether all numbers are between 0 and 5. Yes, you don't have any 6, 7, 8 and all. Next we will get the addend 43.2. Now we have to find the sum. We will just start. What is 4 plus 2? 4 plus 2 is 6. What is the representation of 6? It is 1, 0. So place 0 here and 1 here. Now what is 1 plus 5? It is 6. 6 plus 3 is 9. So 1 plus 5 plus 3 will give you 9. The representation of 9 is 1, 3. So 3 here and 1 here. 1 plus 3 is 4 and 4 plus 4 is 8. What is the representation of 8? It is 1, 2. So 2 here and 1 here. What is 1 plus 1? It is 2. So the sum of these two numbers will be 223.0, or simply you can mention as 223 to the base 6. Just do a decimal addition here. 135.4, 43.2. This is 0.6, this is 8, this is 7. When all these numbers are decimal, this works. That is for base 10, this works. But when it is for base 6, the rules are same, but make sure you use the numbers only from this representation. The next problem will be multiplication. Multiply the numbers in the given base without converting to decimal. 1230 to the base 4 into 23 to the base 4. We will take the base 4 first. 0, 1, 2, 3 will be the numbers. So we will write it as 0, 1, 2, 3. Now what has to accompany in the left side? It is 1. So 1, 1, 1, 1. Now the next set of numbers will be 0, 1, 2, 3, it goes on. And now the next number to proceed in the left is 2. So this is 2, 2, 2, 2. This will be 10, this will be 11. Just have a check. This is 4 power 1 is actually 4. This is 4 plus 0, which is equal to 4. This is 4 plus 1, which is equal to 5. 4 plus 2, which is equal to 6. 4 plus 3, which is equal to 7. Next we have 4 into 2, which is equal to 8. And 8 plus 1 will give you 9. 8 plus 2 will give you 10. 8 plus 3 will give you 11. Now we will get into the multiplication. So we have the multiplicand value and the multiplier value. Our work is to take digit by digit from the multiplier. So the first digit 1230 from the multiplicand and 3 from the multiplier. Just multiply. 0 into 3 is 0. What is 3 into 3? 3 into 3 is 9. What is the representation of 9? It is 2, 1. I will place 1 here and 2 here because I have already multiplied 3 into 3. So I am placing the carry in the proper place. Now what is 2 into 3? 2 into 3 is equal to 6. 6 plus 2 is equal to 8. What is 8 here? 2, 0. I will have 0 here and 2 again. What is 1 into 3? 1 into 3 is 3 and 3 plus 2, the carry, will give 5. So 5 is represented as 1, 1. Since there is no more numbers, I can just place 1, 1 here. So this is the first value that we are getting. Now the second value 1230 into the multiplier 2. This part. 0 into 2 is 0. 3 into 2 is 6. What is the representation of 6? It is 1, 2. So 2 is placed here and 1 is placed here in the appropriate carry place. So what is 2 into 2? It is 4. 4 plus 1 is equal to 5. What is the representation of 5? It is 1, 1. So we will have 1 here and 1 here. What is 1 into 2? The next number, it is 2, and 2 plus the carry 1 is 3. 3 is actually only 3. So we can have 3 here. If you want, you can add the 0, no problem. So 3120 will be the next answer. Now we have left one space here for multiplication. Now we have to find the sum in order to get the product. So 0, we will just write it here. 1 plus 0 is 1. 0 plus 2 is 2. 1 plus 1 is also 2. What is 1 plus 3? 1 plus 3 is 4. The representation of 4 is 1, 0. So I am placing 1, 0 here. So the answer will be 102210 to the base 4. We are using the numbers only from the base 4. For practice problems, we are taking only addition and multiplication, because for subtraction we have a separate topic. I'll meet you in the next video. Thank you, viewers.